Assalamualaikum and good morning everyone. My name is Derented Anateri. My metric number is D2025111860 and together with my group members, we will be presenting our discussion on Microeconomics Tutorial Model 5, Question 2, A, B and C. So we are from group 3. So in this presentation, we will determine whether the given production functions exhibit increasing returns to scale, constant returns to scale, or decreasing returns to scale by applying the returns to scale analysis method. Now, I will explain question 2a. The production function is f in bracket kl equals to k squared l. To find the returns to scale, we increase both inputs capital and labor by t. So, we need to replace k with tk and l with tl. So we got f tk tl equals to in bracket tk squared in bracket tl. After simplifying, we get t power of 3 k squared l. This is the same as t power of 3 f in bracket kl. Since t power of 3 is greater than t, the output increases more than the inputs. Therefore, question 2a shows that increasing returns to scale. In conclusion, when both capital and labor are increased by the same percentage, output increases by a larger percentage, indicating increasing returns to scale. Thank you.
For question 2b, the production function is f of k, l equals square root of kl. To determine the returns to scale, we multiply both inputs, capital and labor, by a positive constant t. So we substitute tk for k and tl for l. That gives us f of tk, tl equals square root of open bracket tk multiplied by tl close bracket. Next, we simplify the expression inside the square root since t multiplied by tl equals t squared kl. The function becomes square root of t squared kl. Using the property of square roots, we can describe this as square root of t squared multiplied by square root of kl. Since the square root of t squared equals t, the expression becomes t multiplied by square root of kl. We know that square root of kl is the original production function, which is f of kl. Therefore, we can write the result as t times f of kl. This means that when all inputs are increased by t times, output also increased by exactly t times. Since output increased in the same proportion as inputs, the production function exhibits constant returns to scale.
For this question, we need to determine whether the production function f kl equals to k0.2 l0.6 exhibits increasing returns to scale, constant returns to scale, or decreasing returns to scale. To analyze returns to scale, both inputs, which are capital K and labor L, are increased proportionally by multiplying them with a common factor represented as t. Therefore, I substitute k with tk and l with tl into the production function, giving f, open the bracket, tk, comma tl, close the bracket, equals to tk 0.2, tl 0.6. Next, I apply the exponent rule where a, b, n equals to a, n, b, n. So this allows the equation to be expanded into t0.2, k0.2 times with t0.6 and l0.6. After that, I combine the terms containing t, resulting in t0.8, open the bracket, k0.2, l0.6, and close the bracket. Since k0.2, l0.6 is the original production function, the equation can be written as t0.8 f, open the bracket, k, comma, l, and close the bracket. To determine the type of returns to scale, I examine the sum of the exponents of capital and labor. In this case, 0.2 plus 0.6 is equals to 0.8. The decision rule states that if the total exponent is greater than 1, the production function exhibits increasing returns to scale. If it equals 1, it shows constant returns to scale, and if it is less than 1, it shows decreasing returns to scale. Since the total exponent is 0.8, which is less than 1, this production function demonstrates decreasing returns to scale. This means that when both capital and labor are increased proportionally, output increases by a smaller proportion than the increase in inputs. For example, if both inputs are doubled, output increases by only 0.8, which is approximately 1.74 times rather than doubling. Therefore, the final conclusion is that production function shows decreasing returns to scale.